Once our measurement model assessment is done, the next step is that we will work on the structural model assessment in SmartPLS. Now, what does it include in structural model assessment? There are 4 things that we need to work on. First, we look for the collinearity issues. Then we work on the path coefficients, their significance and their strength. Then we move on towards the R square, that is coefficient of determination. And then we'll work on the predictive power of our model. These are the 4 things that we include in our structural model assessment. So let's go to our software, and one by one we'll look into the places where we'll get this information. The VIF of the structural model, it can be taken from the algorithm. We'll click on calculate, click on PLS algorithm, the way we did before. And we'll go to the report, and within the report we have collinearity statistics. We'll click on the collinearity statistics, and within these we will go on to the inner model. Now this is the table that we're going to copy paste to our Excel. Now since we only have 3 dependent variables like 2 mediators and 1 dependent variable, we'll just keep those columns in our reporting and we'll delete the rest. Now the criteria value over here is 3.3. If the VIF values are less than 3.3, it means we do not have any collinearity issues and our model is good to go. Now here we are on our model. This was the model that we created. We'll click on calculate, click on the bootstrapping, and we'll make some setting changes. Now we will run complete bootstrapping here. Drop down the menu, complete slower. We'll take that weight. Then because all our hypotheses are generated through the literature, we have directional hypothesis. We are going to have one tail testing here. The level of significance 0.05 and start calculation. All right, now the calculation is done. We'll click on the report. The first thing that we'll check will be our path coefficients here. This is the table that we have. I'll copy this to the Excel. Okay, we'll delete some of the columns from here and we'll change the headings of some of the columns so that they're easier for us. We'll delete the sample mean. And we'll change this original sample to path coefficient. The standard deviation is fine. We'll just remove or we can simply call it SE because this is standard error. T statistics is fine. Just delete the extra information. And the p-value is fine. So we have all of these 4 columns that we want, and we'll keep these one. But there is something important that we need to keep in mind. We are only going to keep the direct effects over here. So I'll put the label over here, direct effects. Now, what are our direct effects? The direct effect are the paths which start from the independent variable and they end onto our final dependent variable. So you remember I only had RQ to PI. That's our direct effect. So I'll remove the other 2 RQ calculations. The website reputation also just from WR to PI, and from attitude towards EVOM to PI, and all others are unrequired. So these are the only 3 paths that we have as our hypothesized direct effects from the independent variable to the final dependent variable. Now, interestingly, none of these direct relationships are significant. If you look at these values over here, all of these values are greater than 0.05, which means that all of these hypotheses are rejected. Now let's move on towards the next set of hypotheses, that would be our indirect. Now where will we get these indirect effects? Over here, a specific indirect effect. Click on the specific indirect effect and copy this table back to the Excel. I don't want this first row because I already have my labels, so I won't keep these. Now from AEW to the PI, that is fine because it has one mediator, that is EWOM adoption. We'll keep this. This does not have our final dependent variable, so I'm weeding it out. This is again something that I want to keep. Review quality to EWOM credibility to PI. This is something that I would want to keep. This is also what I'll keep. All the ones that are ending on PI are the ones that I'm going to keep, except for this one where it is starting from EWOM credibility. I want to have the hypothesis that start with my independent variable and that end on I have only one dependent variable, so it would be on the dependent variable. This one again does not qualify. I'm removing this. And this again, not required. And this is what we have. All right, so I'll just now arrange these in order. I'll keep all the ones that are starting with one independent variable together. I have to check which of these are significant. I'll highlight them with blue. Now you look at this one, it is less than 0.05. This hypothesis is supported. This one is supported. This one is supported. Now in this set, we have this one supported and this one supported. But the one with 0.239, this is not supported because it is greater than 0.05. This is supported way less than 0.05. And this one is also supported. So from these, I have some which are supported, but there are some which are not supported. So I'm going to just copy and paste where I need to make these supported, 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 and supported. And this is not supported. All right. So this is my assessment for which hypotheses are supported and which are not supported. Now, one thing that I can say is that since all of my direct relationships are insignificant, they are not supported. Look, all of these are not supported and not supported. So I can easily conclude that all of these variables have full mediation. Like, I can say it very comfortably for this variable AEW, attitude towards EWOM, that it only has an indirect relationship with purchase intention. It does not have any direct relationship with the purchase intention. Then if I look at the review quality, I have the same point here, that review quality relationship with PI is fully mediated by EWOM credibility and EWOM adoption. Now look at the other one over here, website review or website, what was that? No, it was website reputation. Website reputation is mediated by EWOM credibility and serially by EWOM credibility and EWOM adoption. So these are our hypotheses, our direct and indirect relationships. Next, we are going to check our coefficient of determination. Now, here we are. We'll click on, we just need the original sample and the p-values. All of these R-squares are significant, and one thing important that we need to see the value of these R-square values. So I'll just put here R-square so that we remember that this is R-square and its p-value. if the value of your R square is greater than 0.35, it is a strong explanatory power of the model. So we can comfortably conclude over here that EVOM adaptation, EVOM credibility, and purchase intention. Our model has very strong explanatory power for all of these three variables. Okay, not for these ones because it's not greater than 0.35. So we would say it has moderate explanatory power. But for EVOM adoption, we have a strong explanatory power. Now I'm going to get the effect sizes from the software. Now, this is the place where we get the effect sizes. Look at the quality criteria. Under the quality criteria, we have F square. I'm clicking on that and I'll copy and I'll bring it back to. All right. So again, we have to look at, we would need to sort out this data first. We sort it according to the dependent variable. So all the values that are there with the dependent variable, we'll keep them together. And because we need to put it together with R square. I don't know, the developers should have put these values in, you could say, alignment with the purchase intention, but maybe this is something that they're holding on for the next development. Okay. So EVOM credibility, and we're taking it up. We're playing around with the data. So I'll quickly sort it out and then I'll connect back with you. Now I have sorted out all my data. You can see my R square is aligned with all the dependent variables that we have here. So we'll now analyze group by group. We just need two columns here, the original sample and the p-value, and I'll relabel it. This is my F square. When I'll bring it to Word, I'll type the square as a superscript, but for now I'll just keep it like this. So you can see this is the significant value over here. This one is also significant. Then these two are insignificant. So we can say that the variables attitude towards EVOM and EVOM credibility, they have a significant effect on EVOM adoption. If we look at this set over here, we have two significant variables again, website reputation and attitude towards EVOM. These two variables have significant effect on the EVOM credibility. Now moving on towards the purchase intention. Which ones are significant? Okay, we just have one significant variable over here with the effect size, that is EVOM credibility. Now EVOM credibility has a significant effect on purchase intention. So this is how we are going to interpret the effect size and the coefficient of determination. Moving on to the last portion of our structural model assessment, that is small Now, we're left with only one part of our structural model assessment, that is called out-of-sample predictive power. I'm going to do that assessment in our next video. If you have any questions related to these parts of the structural model assessment, please leave a comment. I'll be really happy to get back to you. Subscribe to this channel so that you don't miss any other future videos. Hope to see you again in the next video.